right, so before the break, we had started talking about MongoDB as the NoSQL database that we were going to use to store all our data. And there are quite different ways that we can structure the data that we're going to be storing. For the assignment, I suggest that you had relationships between various entities such as users or developers, being able to create a number of websites, websites having be related to many types of pages, each page having different widgets, right? So there's quite a few one-to-many, one-to-many, one-to-many relationships, right? And so I wanted to explore how that would be implemented, and also like to consider other types of relationships that you might be able to implement, right? And I wanted to demo how would you implement something like this using MongoDB and in the mean stack. By using a completely different domain, right? But you should be able to extrapolate and reuse the techniques that we're going to be talking about today to be able to complete your assignment. So for the domain that I'd like to consider today is this little class diagram that I drew here, where you have a couple of one-to-many relationships, right? Where you have one university being made up of several colleges, so there's a one-to-many relationship here, right? And then each college offering several courses, right? Again, another one-to-many relationship here, right? This is very parallel to the same thing that you have in your assignment, right? Where you have one developer associated to many websites, one website associated to many pages, and then there's yet one more one-to-many, right? Going from pages to widgets. Yes. So this is the techniques that we're going to be looking at. These three, implementing these three, is the same techniques you would use for completing the assignment, right? But I'd like to consider another one, which is somewhat of an extension, or includes it's a superset of implementing these two, and it's this other way of structuring data, right? And this data allows you to implement a many-to-many relationship, right? Where you might have, in a course, you might have many students register for the same course, right? But that student might be registered in other courses as well, right? So you have a many-to-many, right? You have given a course, you have many students that are registered in that course. But then, given a student, you have many other courses that student is associated to. Make sense? So if you look at it from one point of view, it's a one-to-many, right? Given from the point of view of the course, is a one-to-many, right? So it's the same techniques that you would do to implement this relationship, right, of a university to a college, right? But if you look at it the other way, from a student's point of view, it's also one-to-many, right? Given one student, you have many registration to many courses. Right, so it's the same technique again, right? So if we learn how to do the one-to-many, you could certainly be able to do a one-to-many. All right, so if you know how to do a many-to-many, you definitely know how to do a one-to-many, right? One is a subset of the other, right? So I'd like to explore these two. Notice that this might be yet a little more complicated, right? But I'm simplifying it just to keep it simple. Simplifying to keep it simple. Actually, a course, you don't register for a course. You actually register for a section, right? Because you have one course having many sections, right? And then the student registers for that section. Make sense? But I'm not going to go into that so much. Otherwise, we'll run out of time. So let's explore implementing these two relationships: course, student, and registration. Okay. All right, let's play around with that. So I'm going to start on the server side, right? And if we have time, we'll build also the client side a little bit, at least to just play around with what you have on the server side. But I like to focus more on what's happening in the database, right? And how you would interact with it using Mongoose and to directly talk to the MongoDB database. All right. So let's go into lectures. And let's create a directory for Mongoose where we can play around with the university app. Right. So let's create a little university app, and that university app will have several models, right? And the models might be might be course, right? And the other one might be a student. Okay. And each one of these is going to have its own schema, its own model, right? So let's create the schemas for these. So this will be course dot schema dot server.js, right? And it'll be something like as follows, right? Now, up to this point, we've been looking at the module exports, right, and using a function to implement everything in here. Okay, I'm gonna show you yet another way of doing it, which is somewhat equivalent, but I think it's a little more convenient. All right. Instead, what we're going to do is instead of having the function create some kind of object and then return that object, right? Return that object. Instead, we're going to create the object and then assign it here, okay? Which is somewhat the same, right? But this is a little more convenient. Okay. So let's create that object out here first. All right. So let's see. Let's first bring mongoose. Right. So we're going to require mongoose. There it is. Right. And let's create the schema object in here. Right. Notice that everything that I declare in this file is private to this file. Right. It's not available anywhere else. Right. It's contained inside of this file. So I'm not littering the namespace out there. Right. It's already inside its own module. Right. Because it's a Node.js file. Right. Not the way it would happen if this were on the client side, on the browser side. There, we would need to put it inside of a module using maybe the iffy pattern, right, or some other mechanism. Here, we're on the server side. We don't have those issues, right? So everything that's declared, every variable that's declared here is a local private variable to this file. It's not accessible outside unless you associate it to the exports. That's what exports does, right? Puts something deliberately in the namespace for someone else to use it outside here. Make sense? Right? Okay, so let's create the schema. So this will be a course schema, and we'll use mongoose schema, and we'll declare the schema right here. And let's keep it simple. It'll be just the name of the course, right? So this will be a string. Right? Obviously, we could have a whole bunch of other attributes there, but let's keep it simple so that we can move forward. All right, so we have that schema, and I'm just going to associate the course schema into the exports, meaning other folks who require my schema will have access to that object, course schema. Yes? Remember, the way we used to do it in other lectures, we would create a function, and then the function would return this object. Correct? Okay. All right, so let's do the model now. Okay, the model, this will be course.model.server.js. Okay, so in here, let's see, we're going to create, same thing, we're going to require mongoose. And also, we're going to require the schema that we just created, right? So we're going to say var course schema require, and it's in the same directory, so it'll be course schema. There it is. Notice that it's not a function that I'm calling, right? Right. So there's no need for me to call it here, right? This require does not return a function, so I don't need to invoke it. This is already returns the instance of that schema. Make sense? All right. So I'm ready to create my model here. So I'm going to say var course model, and I'm going to use mongoose to create the model, and I'll give it a unique name, and I'm going to make it unique to my entire website because I have way too many examples and experiments and lectures, right? I don't want this name to collide with any of those, right? Notice that there's only one instance of mongoose, right? And mongoose requires that all models have unique names, yes? And I've created way too many examples and lectures and also for the other section, right? So I don't want to collide with my names, right? So I'm going to forcibly make a very long and convoluted name here, making sure that I don't collide with any of those. So I'll call it, let's see, something like lectures, mongoose, university, right? And then finally the actual name of my model, right? Course. And then I'll use that schema that I just created. So it'll be that course schema. There it is. Right? Something we forgot to do in the schema is to explicitly tell it what collection we want to store this in. Right? So I'm going to say that I want you to explicitly create use the following collection name. Right? And again, I'm gonna use a name here so that it doesn't collide with any other collection name. Right? So I'll use maybe I'm going to use the directory as my example for the name of the collection, right? But the actual name doesn't really have to match anything about the directory, right? It's really that I want it to be unique name in my database. Make sense? All right. All right. So I'll use lectures, mongoose, university example, right? University, and then call this course. Okay. Right, that's the name of the model that's going to be created in the database. Right. Actually, let me verify that I don't already have that name. Let's see. Show DBs, use tests, show collections. Looks like I don't. Okay, very good. So that's not going to collide with anything. Very good. All right, so let's go back to our model. There it is. That's our model. So in our model, we would like to be able to do things such as create new courses, delete courses, find courses. Let's create only the things that we need, right? Just enough for us to illustrate. Really what we want to be able to illustrate today is creating these relationships, right? That's really where I want to get to, right? Being able to, how do you implement those relationships? All right, so let's at least create a course. So let's do function create a course, and presumably somebody's going to pass us an object that represents that course, and we want to create it. So we're going to say course model, and then we're going to say something like create and course. Yes? Right, it's going to go and create that course. All right, that's great. So notice that I'm not using a module.exports function, right? Remember, we're using this new, a little more lean way of exporting things, right? What I'm going to do is that I'm going to export my, one of the things that I used to do in my function, right, was to create an API. Remember that? Right? We would create an object, and then we would return the API. Right, and put in here all my functions. Yes, put all my functions in here. Right. I could do that out here, right? Instead of declaring my export, I could declare this out here. Right, and then just exports my API. Right, we could do that. That would be equivalent. All right, we could do that. Or yet another way. That we would accomplish the same thing is that we could attach the functions right to the course model object, right, using JavaScript's ability to add functions to any object dynamically, right? So let's do that. Let's create the course model. Right, we have the course model, and we're going to attach a new attribute to that object, JavaScript object, right, attached to the function create course. And then what we could do is just return the actual course model. And the course model is going to have everything we need, right? It's going to have all the functions attached to it. Plus, is going to be an actual mongoose model, right? So we could use it outside of this file as an actual course model that would allow you to interact with the database directly, right? Nevertheless, we're not going to use it directly. We're always going to go through its API of creating courses and finding courses and things like that, which provides a higher level abstraction layer, right? That allows us to interact with the database at a higher level abstraction, right? Okay, there we go. We have that. So let's now create a little app that executes this, right? That brings everything together. Let's create an app, right? Maybe let's call it University. The University app. And in here, we're going to bring that model. Let's bring that model. I'm going to say require the model. It's where? It's in models, and then we have course, and we have courses model. There it is. We brought it. Notice that I'm not executing as I used to because it's not a function. Right? It's not a function. So that's going to bring me this. What this is going to do is going to bring me the actual model. So I'm going to say here, this is the course model. Right, now I have course model, and one of the things attached to this object is that function I attached to that JavaScript object, right? So I could right here say course model dot create course and pass it an argument of a course. So I could say name CS5610, right? An actual JSON object that I can pass it and create that course. All right, so let's try it out. Right, so let's require our University JS file from our server so that when we restart the server, it'll run that. Right? Okay, so let's do that. Let's require it right here. We'll say require, and it's in lectures, mongoose, University, and then University JS. Again, it's not a function, so I'm not passing anything to it. So if I restart my server, let's see if this breaks. Okay, so all right, great. Let's see. Notice that the collection is not here, but if I show collections, hopefully it's in here somewhere. Notice that it is, right? There it is. It says lectures.mongoose.university.course, right? So presumably a course was added here, so it's this one right here, right? So that's great. That's promising. Let's look what's in there. And indeed, we have a course added there. See that? CS5610. Right? Let's just add a couple more courses just so that we have a couple courses to play around with. And I think I have something else is being added that I don't want to add from last night. Let's see. Let's create yet a couple more. So CS5200. And let's add maybe IS 1500 and IS 3500. Okay, so if I restart the server and then I look for collections, notice that I have those 4 courses. Everybody good? All right, notice that we're skipping the entire Angular portion of this, right? We're not going through this through a web service. We're going directly by executing the JavaScript on the server, right? So there's no client side to this at all. Right? There are no controllers, no templates, no anything, right? We can add that a little later, right? But we can test this certainly on the server side without the need of a client side yet. So I'm going to comment this out for now. Oops. What happened? What happened? What'd I do? Anyway, I'll just comment it out for now. I can certainly be able to retrieve those courses, right? So for instance, I would like to be able to do something like course model, right? And then says find all courses, right? So let's implement that in the course model. Something like, let's see, function find all courses will be something like course model and then find, right? That's how we know how to do that, right? So it would be something like find, yes? Right? Now the problem with this find, right, is that where the results of retrieving these courses, what can we do? Can we do this? Is that going to return the collection of courses? It's not, right? Right? Intuitively, we would like to do something like this. Right? We say courses, something like that, right? That's what our sequential mind tells us, right? That we should be able to sequentially call this function the function does its work, right, and then returns the results at some point, right? We were taught to think synchronously, right? That things happen from top to bottom, from left to right, right? And things happen stepwise, right? But we know better that the database is running somewhere else, right? I'm running this instead of my IDE from my console, but the server is running in a completely different process, right? So this is a inter-process communication, right? And the only communication is through some network connection that needs to be asynchronous. Yes? And so that won't work, right? So we need to use some kind of asynchronous communication. Yes? So the way the synchronicity works is that these find methods are not synchronous, right? They're not going to return data. Instead, they return data by providing a callback, right? You're going to say, I'm going to go and talk to the database for a second. You go do whatever you're doing, right? And just leave me a callback number so I can call you back when I come back from the server, right? So the way this works is that this finder method has a function, right, that will be invoked at some point later when this successfully or unsuccessfully returns. If it returns unsuccessfully, it will return with an error, or if it returns successfully, then it'll come back with the actual data, right? If it is data, we know that what we're hoping for is that this data is the actual courses, right? The actual courses that are retrieved from the database, right? So how do we return this back to whoever is using, right? If you remember, we had played around with this pattern where we would return, but what would this return? It would return a promise, remember? Right? And then on the other side, we would just need to catch that promise. This would be a promise. Right? And then we would have to do something like promise, can't type today, promise dot then, or something like that. Yes? Okay? And that's fine. That still works. That still works. But I don't know if you remember, we were getting some errors when we were using this, saying that promises have been deprecated, that they're going to be phased out and whatnot, and that we should instead use the asynchronous syntax. And so I'm going to show you what the asynchronous syntax looks like. This is it. But we still need to use promises, just not the promises that Mongoose uses, right? We need to include our own promise mechanism, right? There's a couple of them out there, right? One of the more popular promise libraries, right, is the Q library, right? Which I believe in the package JSON that I provided early on that you're using as a template, right? The Q library is already referenced as a dependency. Okay, so whenever you install this, when you do an npm install, it already downloaded the library, the Q library, which is a promise library, right? And it has its own quirks, right? It has its own way of using it. It has its own, learning curve, and which I'd like to explore that today, right? Yes. Yes, you can use any other one. Those are the two that are recommended by Mongoose, right? Either the Q library or the Bluebird. Yeah, that's equally fine. Yep. So I'm gonna load the Q library. So I'm gonna say require the Q library. And the way this works is that we're not going to return. Instead, right, we're going to create a promise. We're going to create a promise, and we're going to return that promise to whoever is waiting for this, right? And say, hey, wait up, all right? At some point, I'm gonna come back to you with the data that you asked for, right? I'm gonna call you back. Leave me a number so I can call you back with it, right? So we're gonna defer. We're gonna create a deferred promise, right? Using the Q library, so q.defer, right? This is gonna happen asynchronously, meaning the thread, right? The single thread that is the single JavaScript thread is not gonna block here, right? It's gonna call this finder method, yes, this find method, but it's not gonna wait for it to come back. It's just gonna go right past it, And so what we're going to do is we're going to return the promise, which is part of the API. We're going to return the primos. No, jeez, I have a serious dyslexia here. Promise, right? So I'm going to return that promise, and at some point I'm going to notify you, right? And the way I notify you is by resolving the promise, saying, "Yep, now I'm going to call you. Now I have the data, and I can fulfill the promise that I made to you just earlier, and I'll pass you the data that you were waiting for." Okay, so the folk over here that was waiting for it, right? Over here, what they get back is the promise. So this function is what? What does this function return? This function returns this promise right here. Okay, which has a then method on it. So this deferred promise, this promise object has a function in it called the then function, which we can call on it. What does it allow you to do? It allows us to register a callback function that will be invoked at some later time. When will it be called? It will be called when we resolve the promise. When we resolve the promise, this function will be called, and whatever the resolve passes as an argument, that's what we're going to receive. We're going to receive whatever the resolve comes back with. Okay, so finally we're going to get this course here. We're going to do console log courses. Okay, all right. It's a little convoluted, right? But yeah, I hope that we're going to do lots of these examples over and over today, right? And I hope that with repetition, right, it'll get a little easier. And also, obviously, when you go back home today, or you start practicing, the idea is that in your assignment you'll get a chance to practice this, right? And it'll get a little easier the more you do it, right? Practice makes perfect. Okay. All right. So let's do that. Let's run this. Let's see. So this already we created a couple courses. We're just gonna find the courses and just display them. Right. So let's run this. And it blew up. Let's see what it's saying. Final courses. Okay, so it looks like we never added find all courses to this object. So it says that that object does not have find all courses, and indeed the computer is right as always. So we're going to say course model dot find all courses, right, mapped to that. Okay. All right. So let's try this again. All right, there they are. Right. So there's the courses that we had created, and indeed now it's coming back and it's returning it as what we'd expected, right? An array of objects that have been stored in the database. Everybody good? All right, awesome. Okay, yes. Yes, let me point that out. Thank you. Notice that right here we are resolving right away. See that? Irrespective on whether there was an error or not, right? So here we are being very optimistic that we are always returning these courses, but it might not actually be true. So we might check to see if there was an error, right? If there was an error, we don't want to resolve, right? We don't want to resolve. Instead, what we want to do is we want to abort, right, and say, oh, sorry, I know I had promised to pass this data at some point, but I cannot fulfill the promise, right? A rain check, right? So I'll give you instead the error message, right? The error object. I'll pass you if there was no error, then I'm glad to fulfill the promise. Okay. On the other end, right? This then over here, it has the function. This function is a success function, right? This function will be invoked if the promise is resolved, right? If the promise is fulfilled. Okay. Otherwise, if it's not fulfilled, then we can register yet another function, right? One of which will be called. Not both of them. Only one of them will be called, right? One will be called if the promise is fulfilled. The first one, the first function is a success function, whereas the other one will be invoked if there was an error, right? If it was not successful, if an error was thrown or something, right? And in here, we're just going to do a console log the error. Okay, make sense? Everybody good? All right. Okay, let me run this, make sure that we didn't break anything. Okay. All right, I think we have enough to play around with courses, right? Obviously, there's delete and update and all the other CRUD methods that we would like to implement. Yes, but for now, let's go to the students, right? Because what we want to really focus on is being able to create relationships between these two, right? Adding students to courses, right? Registering. We want to be able to register these folks. Okay. So let's do more or less the same exact thing, but for students. All right, it'll give us a chance to practice these new concepts. Okay, all right. So again, let's create the schema using Mongoose. So we'll do student schema, and this will look very similar to what we just did with the course. So we are practicing, right? Practice makes perfect. So let's first load the Mongoose library. So we'll require the Mongoose library. And we'll create the schema. So this is student schema. So this is using the Mongoose library. We're going to create a brand new schema that has the name of the student. Again, I'm just going to keep it simple. Maybe the username, and this is string. And also, we're going to say here the collection we want to use. The collection we want to use is something like lectures, Mongoose, university, and this is student. Okay, that's the collection we want to use. And then just return the student. Oh, actually not return, right? We're going to create a module dot exports equals student schema. Okay. All right. We're going to do the same thing in the model, right? We're going to create the student.model.server.js, and in here. We're going to load the Mongoose library again, right? So require the Mongoose, right? And also we're going to require the schema we just created. So we have the student schema. We're going to require, and it's called something like it's in the same location of student schema. There it is. And notice again, no, it's not a function, right? We're just getting back the object itself. And we're going to create the model. So we're going to say student model using the Mongoose library model. And again, we're going to use a unique name for this. So it'll be something like lectures, Mongoose, university, student. Right? And here, we're going to use the schema, student schema. Very good. All right. Let's see what else. So let's create a student. So we'll create something like a function create student, and we're going to receive a student object, and we create the student object using a student model, right? Student model, and this will be create, and we'll say student. Oops, student. Notice that. In the course model, we had neglected to make this asynchronous, right? I mean, it is asynchronous, right? The thing is that no one's waiting for this to be created. Yes, we're assuming that when it ran and created all these courses, that the several seconds that it took me to go and look in Mongo, that the courses were already there, right? So the few seconds that it took me to type it, by that time, hopefully, it had succeeded in inserting all those things, right? But if we want to create the course programmatically, right, then we would need to add all those promises because somebody needs to wait for it, right, to come back and whatnot, so that somebody can display them at some later time, right? So I'm not gonna do it for now. If we add the services and the controllers and the templates and whatnot, right? We would need to add all those things, right? So just to show you how you would do it, I'm going to do it for the student, Okay, create student, right? So same thing. We need the Q library, right? We need the Q library. We would, same thing, right? We would create a deferred from the Q library, so defer, and we would return the promise. Did I misspell it? No. A deferred.promise, right? So if anybody is waiting for this, right? If anybody's waiting for this, they can use a .then on that promise, right, to synchronize. And so now the create function, right? Remember, we used to do this, right? We used to return a promise object out of this, but again, those are being deprecated, right? Meaning at some point they will not be supported, and our code will be stale, right? So to be forward compatible, we're using the asynchronous syntax, which is a function, right? All these methods, the finder methods, the create, the save, the update, the delete, the remove, right? All those Mongoose functions, they all have the same syntax, right? They might have an argument or not, right? And then they have a function, right? A callback function where they notify you that I'm done, right? I've completed the task, right? Whatever that is, right? Update or remove or find, create, insert, yes? Okay? And they all look the same. They give you the first argument, the first parameter is an error, and the second one is some data. In this case, the data happens to be a brand new course that we just inserted. Yes? Right? So in this case is the course we just inserted. Right? So here we would do something similar like before, right? If there was an error, we're going to abort. We're going to say deferred, sorry, we're not able to fulfill our promise, or otherwise, if there's no error, then we will happily fulfill the promise and pass you the data that successfully was fulfilled. Make sense, right? Notice that I don't really need it on the on my university because I'm not going to wait for creating these students. Right? I'm not going to wait for creating students. Okay. All right. So let me comment this out for now. Finding these courses, I'm not going to use that. We have create student. Let's add it to the student model so that we can call it. So student model dot create student, right, is equal to create student, right, and we're going to return. We're going to say module dot exports equals student model. Okay. So this is my API. This is my API, right? And so now from my university, I can load that model. I can load that model var student model and require it right here, right? Go down to models, go down to students, go down to the student model, and there it is. I have my model. Yes? And now I can create a new student. So I can say I'll say student model dot create student and pass in an object such as that will have a username of Alice, right, and that should create it. Notice that I'm not waiting for it. Notice that I'm not having a then or anything like that. But I could, right? I could. So I could wait for that promise, right? And if it's successful, this function will be invoked, and it will pass me the brand new Alice object students, right, that was added to the database, that was inserted. So let's see. So here's the student, right? And I can console log student, right? Notice that we didn't do this for the course, right? Because actually the course wasn't returning a promise. We weren't doing a then. We were assuming, we were being very optimistic by that it was just creating it. Yes, it had inserted all those things. Here we are programmatically, getting back an asynchronous call saying yes, the student was inserted. Right. So let's try it out. So let's restart this. And module, I must have misspelled it. Module where did I misspell it? Schema module. Sorry. Okay, let's restart. Okay, notice that the oops. What happened? Did I misspell something? Unuser. So username. Sorry about that. Okay. So let's see what was inserted. So if we show the collections, now notice that we have this new collection that was added, and this will be db.find. Well, no, not that one. No, that was not it. Which one was it? Oh, this one? Okay, that one. So db.find. So I added an object, right? But notice that because the schema was not correct, right? Any attributes that were not in the schema were ignored, right? And that's what Mongoose does for us, right? If we were directly talking to the database and inserting, MongoDB wouldn't have cared, right? It's looking at this new attribute. It doesn't care. There are no schemas here, right? That's what Mongoose buys us, right? The abstraction that Mongoose does, right, is that it provides that sanity that it will ignore things that are not valid in the schema. Okay, so let's clear out that bad data. We're going to say remove, and notice I'm going to say notice if I say remove, what would that do? Our intuition is that it would remove everything, right? That's how it would behave in a SQL database, right? In a relational database, when you say, remove something from a table and I don't give a where, right? It would just remove all the records, right? That's the default behavior. Here in MongoDB, the default behavior is that if you don't give it a where clause, right, it won't remove anything. So the default is that if you don't give me a where clause, a predicate, if you don't give me a predicate, right, then I won't remove anything. So if I give it an empty predicate, right, that means that it matches everything. It says, I don't care. Just remove everything. I'm explicitly telling you to remove everything with an empty predicate. And this says it has removed that one record. Make sense? All right? Or if I do a find, notice that it's empty. It doesn't come back with anything. But the collection's still there. The collection's still there. So if I say show collections, lectures, there it is, right? The collection's still there. If I want to completely remove the collection, right, I can say db.students, then drop, right? Very much like you would do in a relational database if you want to drop an entire table, right? You can say drop the table. So same thing here. You want to say the collection, you say .drop, and now if it says show collections, notice that the collection's not there anymore, right? And if I do, if you say drop again, notice it'll come back as false, meaning, sorry, the collection's no longer there. There's nothing to drop. Make sense? All right. All right, so we dropped it. That's fine because we're going to recreate it now, right? When we run it again, hopefully now it'll create Alice. Let's see. There it is. It inserted Alice. And if we go and find the student find, notice that Alice indeed is there. Okay. All right, so let's create yet another, a couple of other students. So let's create Bob. Let's run this. Okay, so we have Alice and Bob, and let's create yet one more, Charlie. Okay, so we have three students and 3 courses, or 4 courses. All right, so now let's play. Now that we have these, right, let's play around with the fact of being able to create or add one to another. Right, and in a relational database, there are a couple of ways of doing it. Okay, if there is depending on the type of relationship. If you're looking at this relationship, which is a one-to-many, right? There's only really one way that you can effectively implement this in a relational database, right? The classical way of implementing this is that the university, the parent entity here, these are all entities. Entities in the class diagrams or classes are implemented as tables in a relational database. Typically, what you have is that the parent entity would have a primary key, which we have, right? Notice that everybody has a key. So everybody has a primary key. I don't have to do anything to have a primary key. Every single record, every document has a primary key. So we have that portion done. But then the child to be able to establish the relationship would have a foreign key, right? Foreign key say, hey, my parent is that one over there, right? These college, the College of Arts and Science, the College of Engineering, all the different colleges, right? Every record for each one of those colleges would have a foreign key whose value would be the primary key of the parent. Okay, and that's what I asked you to do in the assignments, right? Because the assignments are all about parent-child, 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 all the way through. Okay, a more interesting way to implement it, which is not supported by relational databases, right, is that Mongoose allows you to have a different implementation, right? Certainly, Mongo definitely allows you to establish a primary key, foreign key relationship. But MongoDB provides you yet another way of doing it. Okay, something that is more intuitive if you look at it from an object-oriented standpoint. Right. Notice that in a relational database, it is the children who know about their parents. Right. This is completely unintuitive from somebody who's coming from an object-oriented point of view. In an object point of view, if you're looking from a class, implementing a class, right? The way you would implement the university class would have a collection or an array, right, or a list of colleges, right? It would be the parent who would have different references to the children. See that? The children would not know anything about the parent, right? It is the parent who would have an array or a collection or a list, right, or a vector, okay, of instances of the children. Right, so from an object's point of view, it is more intuitive to think of the parent knowing about its children. Whereas in a relational database, it's backwards, right? It is the children who know about the parents, and the parents don't know anything about the children. See that? Right, and that's one of the challenges, right, of mapping these two worlds, right? How do you map, right, data that you are running in an object-oriented world, right? How do you map it into a flat, right, world that is not hierarchical, right, in a flat set of tables? But because MongoDB is by nature, right, at its core, it's an object database. It's not a relational database. Right? That's why we call it NoSQL database. Right? It is not a relational database. We're not storing records. We are storing objects. Right? Those JSON objects. There they are. Right? Here they are. These are JSON objects. Right? And objects can contain other objects. They can contain arrays of objects. Yes. Right. So definitely, MongoDB gives you yet another way of implementing the parent-child relationship. Okay, a parent can have arrays of children. So let's explore these two cases. Right? Let's explore those two cases. So let's explore first the classical way of doing it. Right. So if you go back to the schema, right? Well, here you have to make a decision. You have to make a decision, right? Here it is clear cut who the parent is and who the child is. Yes? You have a university, and a university is made up of colleges. There's a very clear cut decision that who makes up who, right? And once you give me a college, you can also, there is a clear cut determination that a college offers a whole bunch of courses. Yes? There's a clear cut of who makes up who. Right? Who is the whole and who are the parts? Yes? Here is not as clear cut. Right? Here is not clear cut that a course is made up of students. Yeah. Right? But a student is also related to a whole bunch of courses. So it kind of could go both ways of who has a reference to who. Right? Here it is clear cut that in a relational database, it is the colleges who have reference to the university. It is the courses who have references to the college, or if you're doing in Java or C#, it is the university who has an array of colleges, and it's the college who have arrays of courses. See that? It is clear cut. Here, not so much. Do you have courses that have arrays of students? Yeah, I guess so, right? But what about students? Right? Because in these two cases, you like to be able to answer, given a course, what are the students in that course? oh, well, let me look in the array of students in the course. Makes sense, right? But you'd like to be able to answer backwards. Given a student, what courses is that student enrolled in? Oh, let me look in the array of courses. See that? You could go both ways, okay? So it's not clear cut here who is parent and child. So let's explore both cases, right? Let's explore, we'll make the course the parent and the student the child, right? But always keeping in mind that it could go the other way, right? So let's explore that case. So in that case, we would have that the course is the parent and that the student is the child. In that case, we could have, in the classical sense, we would have the child have a reference to the parent, right? If you're going the classical way, right? So we would have here course, my parent course, and I'll have a foreign key, right? A reference to my parent. How do you do that? In Mongoose, the way you do it is by using a type, right, of Mongoose schema dot types dot object ID. Meaning, what I'm going to store here is a foreign key, meaning the ID, the object ID, right? So right here, so I'm going to say, so here you have, here are the students, right? And let me go get my courses. We'll have the courses here. So course, find. There they are, right? We have 3 students and 4 courses. So if I want Alice, Bob, and Charlie, right, to be enrolled in 5610, then they will have a foreign key saying, hey, we are all enrolled in that course, right? So they'll all have a reference to this ID right here, 58 blah, 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 644, saying that we're all enrolled in that course, right? Notice how limiting that is, right? Because that's saying that a student can only be enrolled in one course at a time, right? We're totally forgetting the many-to-many part here, right? But because we're only exploring the one-to-many, yes? All right, we'll explore many-to-many in a minute. So let's look at this one-to-many first. So there it is. So we have a course. What course is this student in? In that ID, the course who has that ID. Okay, and it's referencing the following model. It needs to know this ID is referencing what? What is it? Is it a course I'm referencing? Yes, you are referencing a course. So I need to give it the name of the model. The name of the model. And we chose this convoluted name right here. So this says that I'm going to store IDs. I'm going to store these things, these IDs, right, of courses. These IDs of courses. And the way you should interpret these IDs, is that these are courses. Notice that all objects have IDs. See that? Student objects have IDs. Courses have IDs. Right? So we need to give it a little bit of metadata of saying how should you interpret that ID. Yes? Right? We need to give it that metadata. Right? Saying that, ooh, that ID is actually referencing these things, these objects over here. Not universities, not sections, not faculty, but courses. Yes? All right, great. Okay, so I have that. Let me now we can start adding students to courses. Yes? Let's do that. Right. So to create to manage relationships, right? Let's add here in the model. In the student model, we would like to say something like, for instance, we would like to do something like, we'd like to be able to say, hey, student model, right? Enroll student in course. And I'll give you the student ID of the student that I want to enroll, right? And I'll give you the ID of the course that I want to enroll them in, right? And I'll implement it in a function of the same name. Oops. Oosh. There it is, all right? And we'll implement it right here. I'm going to say function. I'll say, I'll give you the student ID. student of the student I want to enroll, right? And I'll give you the course ID, right? Okay, so presumably the course already exists and the student already exists, right? The records already exist. So to do that, we're going to first have to go fetch that student, right? So let me go fetch that student. So student model, right? Find. Okay, notice that this find is the native find, right? It's the native Mongoose find, right? So this could be find by ID, and I give it student ID. All right, and then that student ID, we could actually instead of this is not the only place where we're going to be using this find by ID, all right? So so ideally, perhaps we should create a separate find student by ID, right? And we get the student ID, and in here we could put the query, this query over here, right? So let's put this nice in here. So it'll be student model dot find by ID, and we'll find it by student ID, and this will come back hopefully either with an error or the actual student object. Yes? Okay, and whoever wants this object, the student object, will have to wait for that, right? With a promise. Okay, so this will be var, again, deferred. I'm going to just type just D. So it'll be q.defer, and we'll return d.promise. And here we're going to either resolve or abort, right? I'm going to skip student. I'm going to skip the abort part just for time reasons, but nevertheless you would put it in there, right? So I'm going to be optimistic, and I'm just going to resolve the promise. I'm going to resolve the promise passing the student object. Yes, right? So now I can use this here. I can use the enroll student in course by first finding the student. Yes, so I find the student by ID. Now that I have the student, function student. Right, now that I have the student, I can modify that student. Right, I can say student dot course. Right, and remember what we store in that field is the key. Right, it's the primary key of who I am referring to. Who am I referring to? To that course ID that you gave me. There it is. See that? Right? Now that I'm done, notice that what I've modified here is the object that is in RAM. Right? Remember, there's a whatever object I get here in Node.js, it's always going to be a copy of whatever is actually stored in the database. Yes? Right? So there's a time between. Unfortunately, there's a lag, right, between me fetching the object, being copied in RAM, right, and somebody perhaps having access to that object still, right? So, but for a couple milliseconds here, I have a stale copy of whatever's in the database, right, the actual object in the database, right? So we might want to have to consider transactions and whatnot. We're not going to talk about those here. We're going to assume that I am the only one accessing this, okay? But nevertheless, I have a copy of whatever's in the database. I am modifying that copy that is in RAM right now, right, in my Node.js instance, right? Even though I modified in RAM, the database hasn't changed yet, right? I need to go back and save this back into the database. I need to say, hey, database, I have just updated this in RAM. I need to now notify the database that this has changed, right? So to do that, we're going to go back to the database and save. Right? Save says this object is now. I want to be able to save it back into the database. Right? Notice that this is a little bit unintuitive. It's a little bit unintuitive because the intuition tells us that this is just a plain old JSON object. Right? We're expecting to have attributes such as username, right? Plus, I know there's a couple of meta attributes in there, such as underscore ID. I think I've seen an underscore V attribute in there, right? Those are kind of metadata of the infrastructure that are added, right? But not only are those attributes added, okay, those magical attribute objects, but also, notice, look at this. This function, that function is also added to that object. So this is not a plain old JSON object, right? This is an expanded object, right? So it's a smart object, right? This is an object that is keeping track of anything you do to that object, right? If you touch that object like we did, right, it keeps track of it and says, ooh, that object that I gave you from the database, right? It was pristine from the database, right? I gave it to you clean. You have dirtied it, right? It is no longer pristine. It is dirty. Or meaning that for now, for this, when you did that change, now the instance that is in the database and the instance that you have in RAM are not synchronized. See that? Right? They don't have the same data. Right? You now are owner of a stale object, right? That is not exactly what is in the database, right? Not until I save it, right? So it gives me all these extended functionality to save it, to remove it. I could remove it. I could find it. Now that I have it, remove it. I'm not going to do that. I'm going to save it. Okay, now I saved it. It will go back to the database asynchronously. That meaning that since this is asynchronous, I need to manage promises, right? That save is going to notify me with either an error or the data. Not that I care about the data, but here is where I am going to resolve my promise. So here we're going to sandwich this call between a defer and a promise. I'm going to say var d equal q dot defer, and then return the promise here, var d dot promise. So whoever's waiting for this, right? We can synchronize by me resolving this, resolve, and I'll pass you the data, whatever that is. Everybody okay? Right? Okay, great. So let's actually do this, right? Let's go back. Oops, looks like I have an error somewhere. Var. Oh, this is return, right? I'm sorry, where? Was that okay? All right, so let's see. Enroll. I have it right there. Good. And let me go back to my university. And so instead of creating all these students, I'm not going to create the students. I'm just going to comment that out. Instead, I am going to enroll. I'm going to copy that. Dot enroll. And I'm going to enroll. Let's see. Let's enroll. Let's enroll Alice. Right, and let's enroll Alice and 5610. Okay, notice that even though it's returning a promise, I'm not waiting for it, right? Or what could we do? Maybe we could do something. Let's see. We could say a then, right? Because remember, this returns a promise, and let's see what it returns. So this is the data, and we're going to console log the data that comes back from doing that. Okay, so let's run that. Let's see if we get an error. Notice that it returned the Alice object, right? This, right? There it is. It says Alice, and notice that now Alice knows, right, that its parent is this course. Having established a relationship between Alice and the course, right? Assuming that there's a one-to-many only, right? There's only one course. Right, and a student can, there's many courses, but a student can ever enroll in one of them, right? You can have many students that are enrolled in that same course. Okay, so let's enroll someone else. Let's enroll, let's enroll Bob in that course as well. So let's enroll that student in the same exact course. So let's run that. Let's run it again. Okay, so now it says that Bob is enrolled in that course. See that? If we go to Mongo, and find the courses. The courses haven't changed, right? The courses are the parents, right? And like a relational database, right, where you have a one-to-many, the parent never knows anything about the children, right? The courses haven't changed. They don't know anything about the child, right? But the children have changed, right, the students, and they all know about their parent, right? Alice knows that it's enrolled in the parent course, and Bob knows that it's enrolled in that parent course. Make sense? Right? Yes?
So the reference is actually stored as the type object ID. So every time when you're doing some operation, do we convert that into an object ID or just pass a string?
Yeah, Mongoose is smart enough to know that that string will be converted into an object. You don't have to explicitly do that. Yes, if you do it here at the command line, yes, you have to do it there. Yes. Also, if you use the native plugin, the MongoDB API, you have to do it explicitly. Mongoose abstracts that and understands. Okay, this is a string. I'll convert it into an object ID, and then I'll use the object ID. Right, so it makes that a little bit more simple. Yep. Everybody okay? All right. So the other way to implement this is to go the object way, right? The object-oriented way, right? The object-oriented way says, wait a minute, this is not how I think about it in object orientation, right? In object orientation, it is the parent who knows about the children, right? So let's explore that example, right? And the assignment asks you to do both, right? To explore both. You wouldn't really do both. Right? This is only an academic exercise, so you get to practice to doing both. You won't do actually both, right? You would choose one or the other. Okay. All right. So let's do that. Let's explore where the parent. Again, we're deciding that the course is the parent, right? Not necessarily though. We're going to say that it is the parent courses that know about the children students, right? So let's do that. So in this case, it would be the parent course who would know about these students. Notice the plural there, right? The course has students. So this would be an array, a collection of things, right? Where each object would be a reference, right? So these would be mongoose dot schema dot types dot object ID. Okay, and the reference is that these all refer to students, right? So let's go back and go fetch the student model name, which is this convoluted name that we came up with, right? Let's put it in there. Okay, see that? Everybody okay? Right? So in the model. In the course model, let's do the mirror image of what we just did before, right? Right, which we want to register. We want to register a student in a course, right? But this is going to be slightly different, right? The other one made the child know about the parent. Instead, over here, it's going to be the parent who's going to know about the child. Okay. Again, you would choose one or the other, right? Not both. Here, we're just exploring one way or another. Okay. All right. So let's do that. Excuse me. So let's do a function register student in course. I'm gonna use exactly the same name for the function, right? But this is going to be tied to the course model, right? Not the student model. And it's going to take exactly the same arguments, right? So this will be the student ID and the course ID. Yes? Right? So first of all, we need to find the course. Right? We need to find the course. So to do that, let's create a function that finds courses. So find course by ID, and this is the course ID. Am I recording? Yes, right? Yes. Right, so we're going to find the course, always sandwiching everything inside a promise, right? Because somebody is going to wait for this data. So let's create that promise. So d dot equal q dot defer, right? And immediately we're going to return d dot promise. right? And now that we have our sandwich, right, we're going to focus on the innards here. What do? We're going to grab the course model, and we are going to find by ID that course, giving the course ID, and this is going to be the callback where we either get an error or the course if it's successful. Here we would check to see if there's an error. If there's an error, we would abort. So actually, let's do it. Right, if there's an error, right, we are going to abort the promise. Right, we can't fulfill the promise, unfortunately. We're going to say d.abort and pass you back the error. Otherwise, if it is successful, we are going to resolve the promise, right, and pass you the course object. Yes? All right. All right. So in the register over here, we're going to first find the course by ID. Yes, we're going to find the course by ID. Once we have the course, we're going to add that student to the collection of students. Yes? So let's do that. Let's first, again, the sandwich. Let's do the defer, right? q.defer, right? And return d.promise. Okay, and then inside we're going to find the course by ID. There it is. And here is the course ID. There it is, right? This is going to return a promise that is going to receive the actual course object. If it's successful, right, we would also have to handle the error, right? But I'm going to handle just a success. Once we have the course, we can just add to the students, right? Remember, students is a new attribute we just added to the schema, yes? Right, we're going to push, right, onto that array. We're going to push the brand new student that has just enrolled in our course. You see that? Right? And again, we have just modified the array. We need to save it back to the database, right? Notice that when we modify any attribute of these objects, right, we are temporarily out of phase, right, with what's in the database, right? We have to make sure that we quickly update the database, right? Hopefully, we would do it in kind of like a transaction, right, to make sure that no one else has access to those records while we are trying to update something, right? Anyway, so we're going to save this. We're going to say course .save. Save is going to be asynchronous, right, and it's going to notify us whether it was successful or not. And it's going to return the new course object, which is it's brand new, saved into the database, right? And we can then finally resolve the course to whoever is waiting for it. Make sense? Pretty good. Let's add our two new functions. Where let's see, they're down here, right? Actually, let's move this up here. Let's move this up here. It's better if you put it way up here, right? So that you don't force me to scroll all the way down to look at the API. So it's better to have it up here and just export it right here. If somebody wants to look at the implementation, they can scroll, right, and look at of each one of the functions. But I'm not forced to do so. So let's see. So course model. My new functions is this register student in course, right? And this my also have a brand new function that allows me to find a course by ID. Find course by ID. There we go. Okay, everybody good? All right. All right. So let's go back to the university and let's comment this out. And let's see. We're going to use now instead the course model. We say course model dot. And the function is register student in course, right? And this is going to take as argument the student ID and the course ID, okay? And let's look at the database. So the database says that I have the following courses, and I have Alice and Bob are both enrolled to 5610. Yes. So let's do the same. Let's exercise the brand new API we just created. Right, so that these coincide, right? That if I go through the students and I ask who's enrolled in 5610, Alice and Bob will come back, right? If I ask the course, it should be consistent, right? That's the problem of doing both, right? If you do both, you run into a problem of a risk of inconsistency, right? Where it says, wait a minute, if I ask the students who's enrolled, it might tell me something. If I ask the courses, it might tell me something else, right? So we want to avoid having to have both things be inconsistent. So anyway, we're only exercising this to play around here. All right, so let's enroll. We know the course ID is going to be this, right? So we know that that's the course ID. What about the students? Let's see. First, we want Alice. Here's Alice. Let me take that the Alice's ID. There it is, right? So first, let's register Alice, and then let's register Bob. So Bob, here's Bob's ID, and there it is. So I'm going to add that. Very good. Both enrolled in 5610. Okay, so let's run that. Okay. And if we now look for the students haven't changed, right? The students, again, right, they know about the parent, but what about the courses? Let's look at the courses. Now look that the courses, 5610 down here, see that 5610? Has now the attribute students, which wasn't there earlier. See that? And both of them have the arrays, right? Have arrays, the IDs of Alice and Bob. See that? Okay. So we've explored both cases, right? Where you have a one-to-many, and we've implemented it in both ways. We've implemented it in the classical foreign key referring to parent key, and that's the only choice you have in a relational database, right? That's the only choice you have here. MongoDB allows you to go that way, right? If you want to keep doing it the classical way, the way relational, if you feel comfortable going that way because it just makes sense to you because you've done relational databases all this time, yes? But it gives you more flexibility. So if you're going to want to go the other way, which is perhaps more intuitive if you come from the object world, if you've never done relational databases before, right? The more intuitive thing for you to think is that, oh no, it'll be the parent, the course, who has the arrays to the students. Make sense? Right? Okay, great. Right, so we've explored implementing one-to-many, right, in two different ways, right? Using the classical and using the new parent having collections of children, right? In the assignment, I asked you to do both, right? Which is you would do the same thing we just did for courses and students. You would do the same thing for developers and websites, and then you would do it again for websites and pages, and yet another one between pages and widgets. Yes, right? This is exactly what we did. All right. So I'm going to leave that there. I want to explore yet another idea here, which is not in the assignment. Okay, it's not in the assignment, but nevertheless, it's very important to understand, is many-to-many. Right? Many-to-many also has quite a few different ways of implementing. Right? You can either have, for instance, one of the problems we have here is that Alice right now can only be registered in a single course, which makes no sense, right? Intuitively, and also by the diagram. The diagram tells us that it's a many-to-many, right? That the student can be enrolled in many courses, and a course can have many students enrolled, right? Right. So the classical way to implement this in a relational database, right, is to have an actual table called registrations, right, or registration, that has a foreign key to both records, right? Establishing a relationship, saying that, hey, that course over there is associated to that student over there, right? That's a classical way of doing it, and we'll explore that. But yet another way. Certainly you can go that way, right? MongoDB allows you to implement it the classical way that you would do it using this mapping table. Usually these are referred to as mapping table or association tables, right? The tables that create associations between two records, saying, hey, that record over there is associated to that record over there, right? and you can have many of these, right, entering associated to many of those, right? So where you can have the course being repeated many times for individual instances of the other ones, right? So you can certainly do that in MongoDB. Okay, but MongoDB goes a little further. MongoDB goes a little further and says not only can you do it that way, but because you have these collections, right, where an object can contain an array, right, an array of children's, right, you can go that other way, right? You can go that way. So let's explore both implementations. Okay. So for instance, if you have registration, right, so you would have a separate schema and a separate model, right? So you would have here registration, right? So this is the classic. Let's look at the classical way that you would implement it, right? So you would have here JavaScript. You would have the schema. So registration schema dot server.js. And then you would have the model that goes along with it. So you would have registration.model.server.js. Okay. Now in the schema, you have things such as let's load mongoose, and so that's require mongoose, right? And you would have here let's create a registration schema, and here you would have the references to both to a course and to a student, right? So you would have here the course would have here a reference, right? So this is mongoose.schema.types.object_id. Object ID, there it is, and it references the course model. So let's go get the course model, that name, convoluted name, there it is, and I'll put it in there. There we go. But students, it would be the same thing. So let me copy that, right? And the model for that students, let's go fetch that as well. Here's the student model, and let me paste it in there. There we go. And then we would tell it in what collection do we want to have it, right? So the collection might be something like lecture.mongoose.university.registration. Okay, all right. And what else? Let's see. We would just return. We would say module.exports equal the registration schema. Everybody good? Right, so now let's implement the model. So let's implement the model here. This is the model. The first thing is that we're going to grab a queue, right? Because it looks like we are going to use queue every time, right? So let's bring the queue library in. Let's bring the mongoose library in as well. Require mongoose. And let's also bring in the registration schema. Okay. Require the schema we just created. So registration schema, there it is. Okay. Now that we have the schema, we can implement the model. Registration model. And this is with mongoose dot model, and the name of the model is going to be something like lecture mongoose university, and then registration. And it uses the registration schema. There we go. Everybody still with me? Right? And one of the things that we'd like to be able to do is create the registration. So here we're going to implement the same exact function we used earlier. Right? We're going to say register student and course, and we're going to provide the same exact thing: student ID and the course ID. Right, notice that each one of these, oops, sorry, I'm just registering, equal that, and it's implemented function, implemented here, Okay, there it is, right? So we're going to implement that here, right? So first of all, we're going to have to we're going to create a new instance, right, of a registration object, and then we're going to insert it into the database, right? So typically, what we could do is either create an object, right? Registration with an object like this, whose we're going to create the attribute student, who's going to be the student ID, right? And the course, right, with a course ID. Okay, and now that we have the object, we can just create it, right? We can say registration model dot create and pass the registration object. Registration object. Okay, and this would call back, right, with a function with either an error or the document, and we would have to pass it back to whoever might be waiting for this, right? So again, we need to sandwich this inside of a promise, right? So we're going to say var d q dot defer and return the q dot promise, right? And resolve it right here. Say so. This would be d dot resolve and pass in the document. I think that's it, right? Okay. All right. So we have this. We've exported. Did we export it? We did not export it. So this is the API, right? This is the API. And then we're going to export it. We're going to say module dot exports is equal to registration model. There we go. Yes? All right. So going back to our university, right? Let's comment that out. So instead, we're going to use the registration model. Registration model. Right. That's going to require going down into the models, going down into registration. Right. And here we're going to use the registration model, and I want to register student, and I want to pass it the same exact information I had earlier, right? We want to create it. Notice that we're exploring different ways of doing the same thing, right? You wouldn't do all of them, right? You would choose one or another, okay? And then we have that, and let's register them over here, okay? Obviously, if you were doing it as a relational database, you only have one way, okay? In a relational database, you have a little more flexibility on how you would want to implement this, right? Okay, let's see. Let's run this. Let's see if this breaks. Okay, didn't break. Okay, let's see if we look at the if we show collections. There we are. We have lecture. Mongoose University registration. Okay, I get. All right, I think I want it to be lectures Mongoose University registration, but that's fine. So let's see this. Let me fix that. That is bugging me. Let's go into the schema, and it's lectures. All right, let's run this again. Show collections. There they are. So these are the three that we've been playing around with, right? So this is the registration. I'm going to copy that. db.that. I'm going to find, and it has those. I can pretty this. I can. Right, there they are. Right, we have a registration saying that Alice is registered in CS5610, and the other one says that Bob is registered in CS5610. Right? Okay, makes sense. Right. So one more thing is that this is fairly cryptic. Right. Notice that. Right now we have these IDs, right? We have these IDs, and oftentimes we don't really know what the actual data is, right? What the actual data is. In a relational database, what you would typically do is that you would take the three tables, right? where is the course, the student, and the registration, and you would do a join, right? You would say, select, right, and you want to say the students, the username of the students, the course name, right, and you say I want to join with the primary key of students, with the foreign key in the registration, and the foreign key of the course with the primary key of the course, right? You would join all three tables, and you will get the records. You will get this, but the student name, the course ID, the course name, right? Everything nicely read, right? You don't have joins in MongoDB. That's one of the caveats in an object-oriented database, is that you don't have joins, right? You have something that is close to a join. Well, not the database. The database does not certainly implement joins, but the Mongoose provides something that is close to it, right? Which I like to share with you. I'd like to share that with you. Say that in my university, the registrar's office says, okay, I have all this registration. What are all those registrations? So I like to say, give me all the registrations, right? Print me all the registrations. So I like to say registration model dot find all registrations, right? Registrations, right? And obviously this will be a callback, and I like to receive all the registrations, right? And this will be registrations. Yes? Okay. Now we could, this query that I did here, right? This would be the query that I'm looking for, right? Lectures, mongoose, blah 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 blah. Find. It returns me this ugly array of objects that make no sense to me. It's just a whole bunch of gibberish of IDs. Yes. I would actually like to see the user's username and the course's name, right? That's much more useful. But I can't do that because I don't have joins. What do we do? Okay, let's see what we could do. So let's implement this. Let's go back to the model, the registration model, and let's implement that into our API. So we like to do registration model. I like to implement find all registrations, right? Implement it in a function of the same name. Okay, so let's implement it. Let's see what could we do. So function find all registrations. Yes. So obviously, we're going to have to use that query I just showed you that we used at the command line. All right, so let's start there. Let's see. We'll do give me the registration model and find all my registrations. Find them all. Yes, and that's going to return. It's going to return either an error or all the registrations. Okay. What that's going to do is we could just say deferred, right? D dot and resolve, right? Resolve and pass all the registrations, right? Let's see. So this is exactly what we did here, right? This is exactly what we did here, right? We're passing back the registrations, and over here I'm just going to display them. Console log all my registrations. Okay, so if we run this, there they are, right? Those are the registration. This is exactly what I got here. Yes, right? So if I was, if I could read the matrix, right, and all the numbers make sense, and I could look into past the reality, I could see that that student is Alice, right, and that other student is Bob. But I can't read the matrix, so these are just numbers to me, right? I like to go a little further and see what behind the extraction, behind the curtain. So I like to do the joins, right? So to do the joins, right, which are not really joins, right? What this allows us to do is instead, let's not do this. Let's take that out of there, right? What Mongoose allows us to do is go a little further and say dot populate. And this is the closest you're going to have to a join, right? Meaning, go fetch the data, and the data that comes back is, certainly this is the data that comes back from the database. That's all the database has. Right? That's all the database is ever storing. Right? It doesn't know anything about actual users and whatnot. Right? That's stored in a different collection. Here, I just have the IDs. What I'm going to do is says, hey, database, go back and populate, right, this field. Populate the student field. Meaning, you have the ID, go back to the database, and fetch me the record for which this ID, right, refers to. Make sense? Right? I'm going to say populate student. Populate the student. Okay? And then finally we'll do an exec. So exec, this is building a query, right? And you can filter, you can do sorting, you can do all sorts of things, right? So first return me the object, right? Then do some processing, meaning go back and find me some more data, right? Meaning populate this field. Execute the query, right? Because the query could be long things, right? So you can say, find me, then sort it, then filter something that's greater than this, or the salary, the employee salaries between here and there, right? Right. I'm filtering, and then execute the query. And at the end of the query, finally, right, come back to me and notify me that you have all the data. Yes? Now I have the registrations, but with the student field populated. Right? Okay, so if I refresh this, notice now that the registration is a little bit more useful. See that? It's saying the student, instead of just giving me the ID, it actually gives me the object, right? With the name, the username of the user, plus whatever I had in there, first name, last name, user, student ID, blah 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 blah, right? Any object that might be in there. Actually, it might be a little too much, right? I don't care about the underscore ID. I don't care about the underscore V, right? I don't really care about the course because I already know the course, right? It's down there. Notice it's replicated, right? So I could go. I could filter out and say, I don't really want. I don't really want all the fields. I just want the username field. I only want the username field, especially because oftentimes, as a report, to fill out a report, I might only care about certain subfields, right? Not all of them. So if I restart, right, you'll notice that now it's a little bit filtered out. Notice that I don't have course, I don't have underscore V. I still have underscore ID, right? By default, that's not removed. By default, it's not removed. You have to explicitly remove it. Tell it that I don't even want the ID, right? Because I already have the ID. Okay. Well, actually, I don't. Right? I don't have. So actually, I might want to keep it. But if I want to remove it because I'm just displaying this, I can tell it and keep telling it minus, meaning I don't want the following field. I don't want the following field, right? And I can refresh here and notice that I only have the username. Make sense? What about the course though? The course is still an ID. The course is still an ID. I can keep going, and I can use another populate. I can use another populate. It says, now you did that for the users. Now I want you to also populate the course, right? And I only want the name of the course, and I don't want the underscore ID. There they are. See that? So this is much more useful, right? I get the actual fields, right? Alice, the course ID, right? Now I could make a table, right, of all the usernames, right, and all the courses that everybody's enrolled in, right? The IDs were just useless to me, or only the IDs were useless to me. Does that make sense? Okay. Very useful, and this is the closest you'll get to a promise. I mean, to a join in a relational database. All right. Okay, I hope this will be helpful for your assignments. Okay. All right. Thank you.